Welcome to the 6.5 notes. Today we're going to be talking about exponential equations. Exponential equations are equations where the exponent is a variable, which we've seen several times this unit so far. I just want you to know that when I say an exponential equation, I mean that you got an exponent and that exponent is a variable like this. And what we're going to be using today is called the exponential property of equality. And what it is that if you have a to some power, let's say b, and it equals a to another power, let's say c, if these two things are going to be equal, then the exponents have to be equal. For instance, 2 to the third power is going to equal 2 to the third power. If you have 2 to the power of x equals 2 to the power of, say, 12, you don't need to calculate anything there. X has to be 12. Okay, that's what the property of equality says. So we're going to be using that today. There is a way you can get things out of the exponent using a logarithm, and we will talk about how to do that, but those are going to be in our log equations. So we'll deal with some exponential equations that need to have logs in the next lesson. The first thing you're going to do is make sure that every exponent has the same base. So notice how I put a base of a on both of those. It has to have the same number down here. Once it has the same number down here, then you can set the exponents equal without writing it as an exponent, kind of like this. Right? And then that's your second step, is set the exponents equal. Or you could also say that the bases or the base goes away. And I'm going to change that because really it should be the same base. So you should make that base go away. And then you have to solve it like a normal algebra equation. It won't have an exponent left anymore. This part can sometimes be kind of hard because it looks so weird to start with. And I'm just going to jump right in. So we have 3 to the power of x plus 1 equals 3 to the power of 5. There is already the same base down there, so you just get to say, oh, x plus 1 would have to be 5. And then you would subtract 1 from both sides. X would have to be 4. That's it. Because 3 to the power of 4 plus 1, well, 4 plus 1 is 5, so that's going to be 3 to the 5th power. And then this next one can be a little tricky sometimes because they both already have a base of 6. That's fine. But this one doesn't have an exponent. Remember that everything already has an exponent automatically of 1. So really, we have 1 equals 2x minus 3. Except for I hate when my equation is set up like this, so I'm going to write equals 1 on the other side instead. It's the same thing. But now I know that I'm going to add my 3 over to here. 1 plus 3 is 4. And divide by 2. And I can even go double check. If I plug in 2, 2 times 2 is 4. 4 minus 3 is 1. 6 to the first equals 6 to the first. And on this last one on the right side, I already have bases of 10. They are already the same, so I just do 3x equals 2x plus 3. And then I am going to write my work for this one because it is a little funky. You're going to want to minus that 2x to the other side. You do have to do the opposite because you're trying to move it to the opposite side. And then that cancels out. This is 3 minus 2, which is just 1x. And then this 3 comes down. Voila. Okay, now those first 3 are super easy because guess what? We didn't actually have to do step 1. But we did set the exponents equal and solve it like a normal equation. And I'm writing the steps up there for you if you need them, but it's way easier if you just understand the nature of the problem. All right, now we start running into some issues on number 4 because there isn't a base of 5 on the other side. So I'm not going to change anything about the left side, but what I'm going to do on the right side is change 125 to 5 to some power. So I'm substituting something for 125. And what I need to substitute is 5 to the third because 5 to the third power equals 125. And when two things are equal like this, you can substitute them. So instead of writing 125, I could write 5 to the third power. And we wouldn't normally do this because it looks crazy, crazier than 125 did, but we have to so that now we have the same base on both sides. And we can just say, oh, hey guys, x equals 3. And you might have already known that this was trying to figure out what power of 5 equals 125. I just wanted to show you what this looks like if you're solving it like a regular equation. And you don't have to solve anything afterwards because x is already by itself. And then in the middle, I have two separate numbers on each side, but they both already have a base. Go with the smaller number because I can't rewrite 2 as a power of any other number. Nothing else goes into 2. But 2 squared is 4. So that's the substitution I'm going to make. And I'm going to keep writing my substitutions up here in the top right-hand corner. That would be a good idea to do if you're having trouble following your work. So then I'm going to come over here and replace 4 with 2 squared. Notice how I replaced it in parentheses. That's usually a good idea, especially because now I can kind of see these two get multiplied together. So this is really 2 to the power of 2x equals 2 to the power of x minus 3. And I have the same base on both sides. So all I have to do is say, hey, 2x minus 3 equals x minus 3. I'm just setting the exponents equal. And then I'm going to minus x from both sides. That's really like minusing 1x if you need the 1 there. 2x minus 1x is just x equals negative 3. And if I plugged that back in, I would have negative 3 and negative 3 minus 3. 4 to the negative third power equals 2 to the negative sixth power because 4 is 2 squared. So you would have to double this one to make it match this one. And I know that's a little confusing to plug it back in, but you can always type 4 to the negative third in your calculator and see if it equals 2 to the negative sixth in your calculator, if those two things have the same decimal. It is going to be a decimal though, because they both have negative exponents, which means this is really 1 over 4 to the third power, and this is really 1 over 2 to the sixth power. But that's just me checking my answer to make sure that I didn't make a mistake. You do not have to do that step. Okay, coming over here to the right, we have 9 and 27. But we run into a slight issue because unlike this one, where 125 was 5 to a power, there is no power of 9 that gives you 27. So instead, what we're going to have to do is find a different number that we can rewrite them both as. And this isn't too tricky because most people know that 3 squared is 9. So I'm going to change 9 to 3 squared, and I'm going to change 27 to 3 cubed. I just need to find a number that I can rewrite both of them as a power of. So then I've got 3 squared and 3 cubed. And I'm going to write them both in parentheses since I said that was a good habit. Now I have to multiply or distribute this. So it's really 3 to the power of 2x plus 4 equals 3 to the power of 3. Because now that I've written it, I realize I didn't actually need those parentheses. I have the same base on both sides. So I can just say 2x plus 4 equals 3. And then I'm solving this like a regular old equation. I'm going to subtract the 4. 3 minus 4 is -1. So I get 2x equals -1. Divide by 2. And don't freak out, your answer is -1/2. Exponents can be fractions. That would actually be the square root and in a fraction. I could go to the denominator and have to do the square root. Okay? And then we have this bottom row. I made all of the bottom row have some fractions. Don't freak out with the fractions, please. 1/36 is simply a power of 6, first of all, because there's already a 6 on this side. And you should know by now that 6 squared is 36. How do you get it to go to the denominator, you ask? Make the exponent negative. Negative exponents make fractions. And I'm going to write that down here at the bottom before we solve the rest of this. Negative exponents make fractions. Okay. And then I'm actually going to add this. Fraction exponents make radicals. Like 1/2 power is the square root. So this is just 6 squared, but you have to add a negative on the 2 because it's not 36, it's 1/36. And that's really the only difference, guys. Because then I changed that side to 6 to the -2nd power. Now I have the same base like I wanted, and I can just say 3x equals -2. Once you get the same base, get rid of it. And then divide by 3 on both sides. Don't freak out, it is possible for fractions to be in the exponent. That's where square roots and cube roots come from. That's it. And then over here, this is 1/2. Since this number didn't change, that would just be 2 to the -1st. Okay, 1/2 is 2 to the -1st power, because it's a 2, but on the bottom. The only way to make it go on the bottom is to give it a negative exponent. But this is really 2 to the 1st power. Put a little 1 right there if that helps you. So then I'm going to change that to 2 to the -1st. And then hopefully you remember from previous problems and just math in general, 2 squared is 4. So this time I had to change both sides again, and now they both have the same base. So I have 2 to the -x equals 2 squared. Okay, -1 times x is -x. That really means -x equals 2. Divide by -1 on both sides. X equals -2. Boom. Find a way to get both sides to have the same base using these substitutions that I have. And the very last one, this one already has a base of 4. I need this one to also have a base of 4. And I know that 4 to the 3rd power is 64. But that's not 64, it's 1/64. So I need to make that 4 to the -3rd power to get over 1/64. So all you have to switch is you need to make the exponent negative. That's really not a tough change. It just looks scary because you've got a fraction in there. And every time our brains see a fraction, they go into panic mode. Now I have the same base, so I can say x plus 1 equals -3. And then I'm going to subtract that 1 on both sides. X equals -4. And what do you know? If I take -4 and plug it back in, -4 plus 1 is -3, and 4 to the -3rd power is 1/64.